Hey, Rivers General here, back with another one. Today we're doing Pythagoras' theorem, what a man from ancient Greece figured out and how we can use this to solve easy, medium or hard exam style questions. Now, without further ado, let's get going. So here we've got easy mode. This is typically the easiest type of question you can get regarding this topic on a GCSE paper. Normally on a foundation tier this will be near the middle of the paper, while on a higher tier this will be in the first 3 questions. So let's get started here. We need to find the length of AB. AB here can be stated as a hypotenuse. What does this mean? Well, this means it's the longest side of a right-hand side triangle. So let's just denote this as C, just as a variable. And this is A and this is B. What do these 3 variables mean? Well, they are part of the Pythagoras' theorem. What does this mean? Well, A squared plus B squared equals C squared is what we use to find this hypotenuse. So this is the Pythagorean theorem. This is the only thing realistically you need to know, and its rearrangements, which will be used in question 2 and in question 3. So to find this specific hypotenuse, using obviously C here as the denotation of the hypotenuse, we just substitute. But what I mean by substituting is just putting, instead of A here in the equation, we just put 6.7, and instead of B here we put 7.5. So what we do is, let's just put our 2 brackets down. Why do we use brackets? Because sometimes, this is a calculator type of question, calculators sometimes do mistakes. In turn they do their order of operations wrong. So we can prevent that by just using brackets. Let's put an add sign here, and obviously this will equal C squared. So what we do is 6.7 squared, add 7.5 squared. Now we just copy this down into our calculator. So we put 6.7, 6.7, we just put the brackets around there, and we put squared, plus 7.5, and we square that also. What we get is 101.14. Now this is obviously equal to C squared. We need C because hypotenuse is denoted here as C. So what we need to do is root this whole thing. So 101.14 needs to be rooted to give you C. So what we do is just press root and this key here, the answer key. Why do we use the answer key instead of just writing this out? A, it's quicker, and B, 99% of the time you will get it correct if you write it like this, but the 1% of the time, when in fact you are under time conditions and pressure, you can potentially misclick, losing you 2 marks. So just root the answer, and what we get is 10.05, 683847. Let me just put a star here and put it up here. We cannot leave it as this because this is too long of a number. Therefore we need to put it to some degree of accuracy. I would recommend 2 significant figures. Why? Because most exam boards and most questions will allow to 2 decimal places if it's just if the question is ambiguous like this. They will basically always allow 2 decimal places. So therefore what we do here is just look at the number. We see that 5th digit is above 5, so therefore we round up, giving us the answer of 10.06, because obviously this increments by 1. Now let's go on to question 2. Question 2 is similar, but here we have C and we have A, but we don't have B. Therefore we're solving for B. Let's just put Pythagoras theorem here. Remember, Pythagoras theorem will not be given to you on the exam paper, you just need to remember it. My kind of year got lucky because we were the final year after COVID to obviously have the privilege to have an equation sheet, but if you do enough revision, what you'll have is you'll remember all of these equations anyway, so you don't need to worry about this. So here we've got A squared plus B squared equals C squared as we had in here, but in fact what we need to do is find B here. So B needs to be, ironically, alone by itself to be solved, like C was here. So what we need to do is move this A to the right hand side, but if we're moving past the equal sign, this is another rule. If you move past the equal sign, you need to change the whatever you're moving, its polarity. What I mean by polarity, if it's a plus, which it is here, it turns into a minus, but if this was minus, it converts into a plus. So therefore, moving across the equal sign, what we have is B squared equals C squared minus A squared. Therefore, this is what we need to now use to calculate for B. So what we need to do is substitution. using these numbers instead of the variables. So what we have is b squared equals c squared, so 5.6 squared, remember your brackets, and then minus a squared, which is obviously minus 4 squared, or we can just write that as, obviously, that as minus 16 here, and then 5.6 squared. This is what we just write in our calculator. Now, b squared, obviously, so what we have is open bracket 5.6 squared minus 16, because 4 squared is 16. So what we therefore get is then an answer of, I don't know, you can see that, we get 15.36, so we just write this here, 36 equals b squared. And then what we need to do is again get only b here, so what we do is just do a root, or a square root of course, of 15.36, which equals b, which equals, after that, just a root of answer, which is 3.919, etc. But obviously we put two significant figures, two decimal places, apologies, that there is a difference to that, which I will say shortly, which obviously gives you 3.92, because the 9 is larger than 5, therefore increments the 1 by 1, which gives you 2. So it's 3.92 for CD. Now, in terms of significant figures and decimal places, significant figures, well, I'll quickly tell you this. This is important when working with these kind of questions. That's when you have, let's say, 101, you have 3 significant figures here, because 1 is your starting figure and everything after that will always be a significant figure. But if you had, like that, 001, for example, you only have 1 significant figure, because 0 doesn't count if it's in front of something which is not 0, but it counts here. So here we've got 2 significant figures. But decimal places are obviously positions after the decimal place, as shown in question 2. Quick lesson over from that, we have question 3 here. Now we need to find EF. EF obviously is here, so we don't have an A, we have a B and we have a C. So we use the same kind of method as we did for number 2. So here what we do is obviously a squared plus b squared equals c squared. So therefore what we need to do is therefore convert this to have a squared on its own. So what we have is a squared equals, here we obviously move the b squared over here, changing its polarity to a minus. So therefore we get c squared minus b squared. Now let's just substitute our numbers in. So a squared, we don't have anything, but we obviously have 8.3 squared, remembering of course the brackets, and then minus 2.1 squared. And then what we can do is just put that in our calculators, like so. We have obviously 8.3 squared, this, like so. Now of course we do then minus 2.1 squared. Remember, just check your numbers here if you've got them correct, and indeed you do. So what we have is therefore a squared equals 64.48 equals a squared. Therefore what we do is just put this here, therefore we obviously root this, so we get 64.48 in a square root equals a, which obviously we then do root answer as we have done for the previous 2, and we got 8.0299, so I'll just write this as such. Let's put it here. So therefore we get a equals 8.0299. Obviously let's use this symbol. This symbol means approximately 2. It's just a shorthand version of doing your to 2 decimal places or to whatever significant figures you need. The 9 here increments the 2 by 1 here, so we get 8.03. So this is easy mode. This is the simplest you're gonna get. Let's go on to medium mode now. So here, ladies and gentlemen, we've got medium mode. This is a little bit more difficult than easy mode, however not too much. The only real differentiator between the two is the fact that we have multiple triangles now, multiple geometrical shapes to work with. Therefore we will need to use Pythagoras' theorem multiple times. Now this can be seen in question 1, where we need to calculate the length of AB. Now AB, as we can see, is here, so let's notate it as we did with easy mode as C. Now therefore this is our A and this is our B, but we can see that this length, let's call this AX, I'll put an X at this point, We don't have that. Normally we would in a easy mode question. So therefore we need to find it ourselves. So this is a two-step problem now, where we need to use, as we can see with the second triangle, we need to use reverse Pythagoras' theorem because we've got the hypotenuse here to find A, and then from A we find C. So let's do that. Let's just write Pythagoras' theorem out again. A squared plus B squared equals C squared. I'm writing this multiple times across all modes so you get used to this theorem so you can remember it easier, and therefore you can do these questions quicker later on. So now we need to reverse this theorem. So as I showed last time, now we want, of course, A squared on its own. So therefore we need to obviously move the B to the other side past the equal sign. So therefore we get A squared equals C squared minus B squared. Now we just substitute, move our values into this equation. Therefore we get A squared equals 9 squared minus, obviously put our brackets around this, minus 6.7 squared brackets. Of course we get our trusty calculator out here and we put 9 squared with our brackets minus 6.7 squared. Now this kind of question will always be on the calculator paper just because we're using quite complex numbers here in addition to multiple triangles. So foundation students, I would personally say this isn't 100% on a calculator paper only, so it's exclusive to that. But for higher level students, the only method of this being on a non-calculator paper is if the numbers are easier to manage. So let's continue. Here we get, of course, the number of 36.11 as A squared. Now we don't actually need to root this like we did with easy mode because we're using A squared anyway for A squared plus B squared equals C squared for the second triangle. So we can just leave it as this. Makes it easier for us. So we have, let's put this as A squared plus obviously 100 equals C squared. So again, we can just say answer here. You can even put answer as a working out mark because they will understand if you're on a calculator paper that you just press the answer symbol. So plus 100 equals C squared. So again, we press plus. We don't even press the answer key because it does it automatically, at least for Casio's. Now what we just do is plus 100 because we're doing 10 squared from B squared. We get C squared as 136.11. And now of course we root this number and we get C as 11.6666. And obviously that continues, but we of course put this to 2 decimal places, giving us an approximate, using the approximate symbol once more, as 11.67. Now, with question 2, we've got this more difficult question that this polygon composes of a rectangle and a triangle, and we need to calculate the length of CD. So CD, we see obviously is this. So from what we know, we need to find this, and I'll put this length as A, and we need to find this length as B to calculate CD as per Pythagoras' theorem. Now, we know obviously that this polygon, as the question says, composes of a rectangle and a triangle. Now, as we know that, we know therefore these sides are parallel to each other and these sides are parallel to each other. And in addition to being parallel, they will also have the same lengths. So let's put this as X, this will also be X, but more crucially, this length, 3.4 centimeters, will be the same as this length, so we can put this as 3.4 also. Now this makes our job way easier. We can then calculate A and then use Pythagoras once more to find CD. So let's do that. First of all, we do reverse Pythagoras again, putting this as C for hypotenuse, and obviously this as B. So therefore we have A squared plus B squared equals C squared. Obviously when you get more proficient, you can kind of shorten this method, but I'm doing this so everyone will here understand what I'm doing. So now what we need to do is obviously make A squared our subject, so make it on its own. Therefore what we do is just put A squared, move our B squared to the other side, so we get A squared is equivalent to C squared minus B squared. Now we substitute our values. We know that C squared is just 12 squared, so we know this is 144 minus 16, So you see, if we get these kind of numbers, that could actually be on a non-calculated paper. Now, we'll see what we get here, so I will still use a calculator here, just in case mental arithmetic isn't your strongest suit. I will still use a calculator. So we get 128, so as we can see, 128 equals our a squared, so therefore we root this value to get a. Root of 128 equals a, or if we want to be more precise, it equals this value. I'm just going to leave it as root 128. Why? Because we're going to be adding 6.1 to it anyway, so it will just be an unneeded procedure to do, therefore it will just be a waste of time. So we have root 128 in here. Now what we do is just answer plus 6.1 centimeters, because we need this whole length to then calculate CD, not just this. And then we get this value, so that's, we just put root 128 plus 6.1 equals 17.413785. Obviously we keep this in our calculator, I'm just putting this as a reference for the examiner, because even in the best case scenario, and even if you're very confident with the answer you put, you could still do a mistake which you've not seen. Therefore it's always good to write everything down what you've put in the calculator, just in case, because that could get you an extra mark for working out, and you never know. So we've got this value. After this we obviously square this, plus our, in brackets, 3.4 squared, and we check obviously our values, and then what we have is answer squared plus 3.4 squared in our brackets, which gives us c squared, and c squared is this value right here. C squared equals 314.7972437, and then obviously we root this, and we get c as 17.7425. Obviously the number goes on, and this is approximate to 2 decimal places, which is 17.74, which equals our length CD. So this is more simple to explain here than easy mode, as you can see, because we've already learned the basics and we're just developing our knowledge using Pythagoras' theorem multiple times over. Now let's go on to hard mode, so I can show you the hardest type of question you can get on a GCSE paper regarding this topic. Right, here's hard mode. So why are these questions so difficult? Well, we don't actually have the geometric shapes before us, we just have plain text. So let's see what question 1 is here. A ruler is slanted against a wall with a length of 30 centimeters. The distance its shadow presents on the wall is x centimeters, and the distance from the ruler's lowest tip to the wall is 5 centimeters less. Calculate both the latter values. So let's see what this means. So let's just draw ourselves this scenario, and we can already kind of see from reading this that this is going to be a type of triangle, isn't it? So here we've got the wall, the physical base which the ruler is on, and the ruler itself. So we know that the ruler has a length of 30 centimeters, which is our hypotenuse. Now we know that the wall has a length of x, and we know that the base, the distance from the lowest tip to the wall, so basically the base of this triangle, is 5 centimeters less than x, so it's x minus 5. Now to find both of the latter values, therefore the wall's value and this base, we need to use algebra and Pythagoras' theorem. This is a decently high level skill. I would personally say if it would be ever on a foundation paper, it will be at the very end, but I would personally say that it's near impossible to be on a foundation paper. This would be more of a high level skill because we're incorporating 2 topics in one here. So let's calculate this. So using Pythagoras' theorem, we know that a squared plus b squared is in fact c squared, as we know from the 2 previous difficulties. Now what we need to understand is that we need to substitute these variables as if they were values into this equation. So therefore we know that a squared becomes x squared, plus obviously x minus 5 squared, equals 30 squared. Now let's just simplify this, so x squared still plus x minus 5 squared equals 900, because 30 squared of course. Now what we need to do is here we need to expand these brackets. So expanding brackets, I'll kind of explain this to you. What you need to do first is just write x minus 5 like this, twice, because obviously, well, we're squaring here, so we obviously need both of these. Now to expand these brackets, what we need to do is do the FOIL method. Now what's the FOIL method? Well, foiling is timesing every single value in every single combination. What do I mean by this? Is that we need to times x by x, let's call this f, and then O is x times minus 5, I is x times minus 5 again, of course, and our final one is L, which is minus 5 times minus 5. Now let's just simplify this, so I'll just put an arrow here. Now x times x is of course x squared, minus 5 times x and minus 5 times x both give us obviously minus 5x. If we add these together we get minus 10x, and then minus 5 times minus 5 is plus 25, because minus times a minus is a plus. So that is what we get. Now obviously we then put this back into our equation. We get x squared plus x squared minus 10x plus 25 equals 900. Then obviously our x squared to combine to give us 2x squared minus 10x plus 25 equals 900. Then obviously if we are doing binomials, which this is technically 1 because it has an x squared in it, we need to have this side equal 0 to do what we call the quadratic formula, which I'm going to show you in a second. We need to take this to the other side, passing again our magical equal sign, therefore making this a minus 900. So therefore what we do with our calculator, we get minus 900 plus 25, which is minus 875. So we get 2x squared minus 10x minus 875 equals 0. Now we need to do the quadratic formula to this. Now how do we do that? Well, you need to learn this. So the quadratic formula basically states minus b plus minus the square root of b squared minus 4ac over 2a. Now this sounds horrendously complicated, but it really isn't. Now think of these numbers here as a, b and c. So 2 is a, minus 10 is b, and minus 875 is c. Now what we need to do is substitute these numbers in the correct locations in this formula. So this of course now equals minus b is obviously positive 10, plus minus the square root of b squared, which is 100, because minus 10 times minus 10 is 100, minus 4 times a times c. Now we know that we 4 times that by 2, and then times it by our massive c here, so what we do is times minus 875, we get minus 7,000, so what we do here is just put minus again 7,000 over 2a, where a is 2, so 2 times 2 is 4, and then we put an equal sign there. We can simplify this further by just saying 10 plus or minus the root of 7,100, because minus and minus here make a plus sign, plus 7,100 over 4. Now what does plus or minus mean? It means that with the quadratic formula in our calculator, we must do 2 scenarios. We need to do one scenario where this is a plus root 7,100, or a minus root 7,100. So 10 plus root of 7,100 divided by 4 equals 23.565, and it just carries on. And our minus scenario is minus 18.96537, whatever. This doesn't count because a value in the real world cannot be a minus. You can't have a negative distance. So therefore we know that our answer will be akin to this. Therefore I'll just move this upwards for you guys. We need to do this to 2 decimal places now. Therefore when we have this to 2 decimal places, we have 23.57 centimeters. Now that's our x, so we put that as equal to x, and then we of course put this value once more in our calculators. Over 4, we get that value once more. Now we then take away 5 from this to get our base here. Therefore we get, for x minus 5, we get 18.57 once more, which equals x minus 5. So that is our answer for question 1. So let's go on to question 2 now. Now in terms of question 2, we have a phone that has a screen size of 15 inches measured diagonally and a ratio of the length to the width of the screen as 4:7. We now need to calculate the length and the width of the screen in centimeters. Now let's circle some keywords, shall we here? Now first of all we have inches here, and we need to calculate in centimeters, and as you can see 1 inch equals 2.54 centimeters. You are always given conversions from imperial to metric in GCSE exams. They don't want you to remember them, so don't worry about that. And as you can see we have a ratio of the length to the width as 4:7. So now to kind of fully understand this, we need to visually draw it. So first of all we have a length here and a width. Now of course, as we can see from the ratio, we have the length as 4 and the width as 7. But what we need to remember is that we need to add n. What is n? N is our scale factor. It is a way of increasing the size of the screen, but still keeping it in proportion with 4 and 7, because we will be multiplying n by those respective 2 integers. So we need to find n to find the length and the width of the screen. Now what we also have is our hypotenuse, the diagonal line here, which is 15 inches. Now 15 inches, we can either convert that into centimeters now and then just work in centimeters, or we can convert at the very end after we work in inches. I recommend the prior because you only convert into centimeters once, not twice, for both the length and the width. Now what we do is, I'll write it here, 15 times 2.54 in our calculators, because we're converting from inches, 15 inches, to our centimeters using that conversion. We therefore get 38.1 centimeters. Now this would most likely be a mark in a GCSE exam, just doing that. After which, we just write a squared plus b squared equals c squared, our Pythagorean theorem. So therefore what we do here is just put 4n squared, outside bracket here, plus 7n squared equals 38.1 centimeters squared. As you can see, I have now substituted the numbers into this equation. Now why have I put the squared outside the brackets, not inside? Because that can cause confusion, because we know what we're doing, but the examiner, when they will be looking at this, they'll be like, wait a minute, but you need to square all of it, not just have the n be already squared. So that's why you put this outside the brackets. So let's carry on here. All you do is trusty calculator, 38.1, square that. We get this number, 1451.61. And obviously we therefore square these values inside our brackets, so obviously we get 16n squared. Why do we get 16n squared? Because we're raising both the 4 and the n to the second power, so therefore we get 4 times 4 is 16 and n times n is n squared. We do the same thing here with 7n, and we square 7, which is 49, and then we square n, which gives us n squared. Now what we need to do is add our 16n squared to our 49n squared, which gives us 65n squared, which still equals our 1451.61. Now, to find n on its own, to obviously get our scale factor here, we now need to divide both sides by 65, which therefore gives us the following of 1451.61 divided by 65, which gives us 22.33246154. Now we obviously root this number, which gives us 4.725723388. Obviously this root sign here. So we obviously keep that in our calculator, and that's our scale factor. To find our length then, we times that scale factor by 4, and we indeed get 18.902, just 902. Approximately, obviously we have more digits, but we don't even care about these. Then we put this to 2 decimal places, which is 18.90, which we can then state as length. And obviously divide by 4 to get our scale factor back, and then we times by 7 for obviously our width, and we know that's obviously 33.080, which for 2 decimal places gives us 33.08, which is our width. And because obviously we converted in the first place, these are all, of course, in centimeters. Now, this was hard mode. Now, let's go to the outro. So that was Pythagoras' theorem. I believe that this topic is an essential building block for the harder difficulty questions which you can see on a higher paper, which are grade 7, grade 8 and grade 9 difficulty. So if you have aspirations to do the higher tier, I'll personally recommend you to master this topic before going further, because it will take you way more time to master those topics without knowing these basics. Now next week we're doing bearings, what they are and how they work, so stay tuned, like, subscribe, do what you need to do, and goodbye.